So my name is Jackie, and I'm joined by Jess, and we're both here from Bloomberg, and we're here to talk about complex architecture and our experiences in the context of what we've done in our jobs at Bloomberg, and just things that we've learned over our experience in terms of how to maybe approach architecture, how to approach making things less complex to make it easier to understand, maintain, get onboarded. So I kind of want to start off just by defining what complexity is, because it can mean a lot of different things, different contexts. This is a very great description from Wikipedia about complexity in the context of software engineering. So I'll just read it. It says, complexity characterizes the behavior of a system whose components interact in multiple ways and follow local rules, leading to nonlinearity, randomness, and collective dynamics. And I've highlighted what I think are the most important aspects of the definition is this concept that things can interact in multiple ways. There's this optionality of if I look at a component, if I look at a service or a system, what is it doing? It's hard to know off the bat just by looking at it what it's actually supposed to be doing. And also this concept of local rules, meaning looking at it in isolation is not going to be sufficient to know how it's going to behave. So I need to look at all the other components that are associated to it to understand what it's actually supposed to be doing. And I think this is the reason why things are really complex, is we can't look at things and know how to use them or to write code or to interact. And there's a lot of different ways that things can behave or act in the context of other things. So quick introduction to myself. So I said my name is Jackie Pan. I'm a software engineering manager at Bloomberg. Bloomberg, for those of you who don't know, it's actually one of the sponsors of this conference, so maybe everyone here does know what Bloomberg is, but Bloomberg is basically a financial software company that primarily focuses on analytics and trading systems, but also is involved in many other industry verticals, such as Bloomberg.com, Bloomberg News, et cetera. I've been at Bloomberg for 6 years, almost 7 years. I've actually been on 7 different engineering teams at Bloomberg, so that's a fun fact about me, and if you want to come talk about it afterwards, feel free to reach out. And I recently joined a new team at Bloomberg called ESG, which I'll talk about a bit as well. And a little fun fact about myself, so I'm very passionate about automated testing. So the fun fact is actually last year was my first time speaking at a conference at ACCU, so shout out to ACCU. And anyone who's interested in speaking at ACCU, definitely feel free to reach out. I'm happy to share my experience doing it for the first time, but I spoke about BDD. BDD is behavior-driven development. We'll talk a little bit about that as well later, but if you want to talk more about that, feel free to come reach out to me and Jess afterwards as well. Also last year, I joined the ACCU conference programming committee, also first time. So anyone who's interested in getting involved, come talk to me. We'd love to involve more people as well. At Bloomberg, I'm involved in what's called an automation guild. So we have these communities at Bloomberg that are technical communities. Basically, if you think about back in the day in school and university, there might have been clubs, things that you're passionate about, involved with outside of your day-to-day activities. So I'm very passionate about testing. So we have this community at Bloomberg, people who are really passionate about sharing how to test, what tools to use, and so forth. So if you're interested, feel free to reach out afterwards as well. So about my team, I mentioned ESG. So what is ESG? ESG is basically, it stands for environment, social, and governance. And what my team does is we build software to compute ESG scores. We compute the score for a company to evaluate its sustainability and ethical impact. ESG, environment, social, governance. So environment, for example, could be for a company, what is their carbon emissions? How much carbon emissions do they have year after year? Social might be what kind of health and safety policies do they have for their employees? How are they protecting their employees? What does that look like? And then governance can be about the board, can be about how you govern the company. So an example of that might be board diversity. How many women do you have on your board? And what does that mean in the context of the entire company and the industry? My team is quite new. So we've been, ESG in general is kind of a new concept. I'm not sure if everyone here has heard of it, but there's a lot of regulations coming out specifically in the UK. So you probably will hear more about it in some context over the next year. But my team in particular, we're building a new system. We call it Pipeline 2.0, and it's basically a distributed system to compute these scores. And you'll see an architecture diagram later about what it looks like. But it's only a year old. And so maybe you're asking me, okay, well, why is this so complex? I'm talking about complexity in architecture, but your team is new, so why is it so complex? And the reason why my team in particular is complex is because the industry that we're in is constantly evolving. So a lot of regulations around how companies should disclose information about ESG has not fully been put into place. There are still new regulations coming out. Things are constantly evolving. And as an engineering team, we constantly have to adapt. Every time something new comes out, we have to make sure that our system can support it. And a fun fact, so I don't know if anyone here is familiar, but there's this conference at the end of every year in November called COP28, or it's called COP, but every year it's COP28, COP29, et cetera. Michael Bloomberg, who is the founder of Bloomberg, went to COP28 last year. It's a conference for all the global world leaders to talk about climate change. And oftentimes these conferences, as a result, we come back and we realize, okay, these countries now need to disclose this information. How do we make sure that our scores take that into account? So how do we evolve our software to include these new requirements that come, like every single new month, there might be new things that are coming out that we have to account for. How is our system used? So we're a data analytics system, so it's used by investors. There's a lot of integration to other products at Bloomberg, but also externally. So traders who want to make decisions that are sustainable and ethically have impact, they want to choose companies that have that impact, they might use this data points to make decisions on how they want to trade. So that's kind of how our system is being used. And I'll pass to Jess to talk a little about her team.
Cool. First clicker handoff, exciting. So hi, I'm Jess. I am a software engineer at Bloomberg. I've been there for about 3 years. The fun fact about me is I'm a notorious PR commenter. I love thinking about variable names and refactoring. So my passion in life is to say, ooh, could that variable name be more clear? That sparks joy for me. And then a little bit more about what I do. So I work on a team that works on the automation of post-trade actions. So what that means is that my team, after a trade has been submitted, you've bought your stock or bond, there are actions that need to happen afterwards for that trade to be completed. The trade information needs to be sent to places, and I help with the automation of those actions. But what do I actually do in my day-to-day is less the financial aspect. But I work on a system of many, many interconnected services. I work on a system that is 20 plus years old, which means that most of the people who originally wrote the code are now no longer in that department, which I think is very interesting contrast with Jackie's team, that there's complexity in both very new systems, but also more established systems. We also work on, I work on a product that is used by more than 900 clients, client meaning firms, and there's people at those firms that are using it. So a lot of usage, and then it's also part of the client's trading workflow. So there's a high emphasis on security and on making sure that the financial data is maintained. And then what I actually am working on is we're doing a massive migration from a legacy code base to, quote, new stack. Everything's always new stack. But that means that we're spending a lot of time understanding existing code and translating it into more modernized systems. So I actually wanted to start the talk by taking a really big step back from software engineering and kind of talk about how complexity seeps into everyday life. So I come from New York City, the land of the very tiny shoebox apartments. And last summer I moved house, which means that for the first time in my adult life, I had a kitchen drawer. Woo! And so I had to face kind of the age-old question of how am I going to organize my utensils? So I started off with this system. So I was going to have a section for forks, spoons, and knives, which is fairly straightforward. And then I started unpacking into that drawer, and I found out that I owned soup spoons. Now, I thought those were the same as teaspoons, but my mom called me from states away to inform me that they are different and should be treated as such. I also own steak knives, which are different than butter knives, I was told. So I had to rethink about what do those definitions mean? What do those categorizations mean to me, and how do I want them to be used? I also own sporks, which is a combination spoon/fork. So I had to again think about crossing those boundaries of fork and spoon, and what is the system being used? How am I going to remember to use it? And I also went to Japan and bought some chopsticks. So those fit in none of the prescribed categories. So this is kind of just a fun little example from my life, but I still think it iterates some ideas of software engineering. So what are some utensil takeaways? One, I had to start out by articulating my expectations. How do I think that my system is going to work? Then I had to see it in practice. I had to evaluate the trade-offs of my existing system. Then I had to make compromises. Okay, soup spoons and teaspoons are the same thing, according to me and not according to my mom. And then I had to iterate on that system as I got new information, as the context changed. So, we're taking this idea of everyday life and we're going to apply that to software engineering. So this will also serve as our agenda. Ha ha ha. Okay, so starting with articulating expectations and methods for articulating expectations and having that decode complexity in our system. So I wanted to start by kind of defining our system. So what is everything that you could possibly account for? And I'm representing that by this box. So what this box represents for me is the automation of post-trade actions. I am not calculating ESG scores. I am not making a social media platform. There are a lot of things I'm not doing and are not in this box. There's also within this box, there are the things, what am I purposefully accounting for? It's represented by this lovely blue circle. So these are the things that I think my system does, what we've purposefully accounted for. And you'll notice that it's not the whole box. There's room for future growth. We're still growing. There's still features that we want to add. And these are the features that we currently have. And then I also think there's a kind of pesky other circle in this Venn diagram, which is what I'm unpurposefully accounting for, what my system actually does. I do want to note that there should be more overlap between the two circles than in this diagram, but I do think that they're distinct circles. So why are they different circles? Why do what I think my system does, how can that be different from what my system actually does? And I think that can take two forms. So one is from the engineering perspective. So misunderstanding my code or how it could be used. So for example, I think the product of 1 + 1 would be 2, but actually my code says 1 + 1 = 10. It's a binary joke. Or it could also be from the client perspective of how people are using the function after I've given it to them. So for example, I have a lot of customization points in my code, but how are my clients actually using those customization points? What configurations are important to them? What configuration points are not important to them and they're not using? So I think that there's overlap between these two ideas, but there's also differences, and it's important to identify those differences. And a lot of those differences can be a little bit dangerous. So I wanted to talk about this in the context of Hyrum's law. It's one of my favorite coding laws, which states that with a sufficient number of users of an API, it does not matter what you promise in your contract, all observable behaviors of your system will be depended on by somebody. So that means that that green bit of what my system actually does is what my clients are depending on. And even if I do not think that's what my system does, I have to continue to support that. Or if I'm not supporting that, I have to it should be a conscious decision and not a surprise. So I think that it's very important to think about the kind of distinction between these two circles. So I wanted to think about this Hyrum's law in action. First example. So this is the saga of the I'm ready signal. So I talked about how I am post-trade after a trade has been created. That means that there is a pre-trade when the trade is created, and there's a connection between these 2 points. For our system, that is represented by a RabbitMQ queue. So there are events being published onto this queue with trade information. My team reads off of that and processes that trade information once it's ready. And when we were migrating to the new stack, we had the question for our MVP of, well, what does it mean to be ready? And we were looking through all of the logs and looking through the cases used for our MVP, and we found an event on the RabbitMQ queue that we said represented that I'm ready. It happened at every point that we wanted our system to start. So we declared it the I'm ready signal, and we started using it as such. And we made it a prerequisite for our stack. Our stack would not begin processing until we got the I'm ready signal. And it's important to not start processing before then, because then the trade isn't finished being created. But as we expanded beyond our MVP, we found a few problems when testing on beta. So some questions that we could have asked when making this a dependency. Is this what the signal was intended to mean? Do all trades, all of the possible inputs into our system use this signal? And do the producers of the signal know that it's being used this way? The answer to all of these was no. So that means that when we expanded beyond the MVP, we had to make a fun new design. So we had to add kind of a calculation within our system to say, okay, not only are we going to look for this I'm ready signal on the RabbitMQ, but we're also going to do a separate calculation of what it could mean to be ready and use that for the other trades that aren't being told that they're ready from this original source. And this created 2 sources of truth in our system. And it's been a long migration of trying to figure out which of these prerequisites that we need. So I think that this is kind of an example of how people are using your product can be different. So some takeaways from the I'm Ready signal saga. So one, from the consumer perspective, communicate with the owners up front. We were in the very lucky position that the producers of this signal worked in the same company as the consumers of this signal. We could have gone and talked to them and communicated with them about what the expectations were behind this signal. And we did not do that. Another takeaway from the producer perspective is also that people want to misuse your system. I accidentally want to misuse your system. So it's important to articulate how your system is being used, what it means, so to make it harder to misuse. And I think there's another takeaway from both perspectives, which is that things look different from the different perspectives. What my team had interpreted to mean the I'm ready signal does not necessarily mean from the other perspective that I'm done. I made that a little iceberg because I always really liked the analogy of an iceberg where there's a little bit on the surface and a lot underneath. And I think that that's often true when we're looking at APIs, that the small surface that we see of the API does not capture the big under mechanics of how it works. Okay, so we've talked about how these are different, how they can, you can find flaws in the difference between how people are using your system and what you think it means, which means that a worthwhile goal is, how do I merge these circles? Haha. Or in other words, how do I articulate expectations? So a really useful strategy for articulating your expectations is behavior-driven development, or BDD. So BDD is a strategy for articulating your expectations and using those articulations of the behaviors of your system to drive your development, making those be a primary source of why you're doing the development that you are. So this is a whole talk in and of itself. However, I wanted to highlight some of the points of BDD that I think are the most important, have been the most useful for me. So the first part of this strategy is the idea of collaboration, that the articulation of expectations should be a joint communication between engineers, product, and QA. And a very common follow-up question to this is, what if my company doesn't have QA? Or what if my company doesn't have a dedicated QA team or a dedicated product team? What do I do then? And so I think it's important to think about, well, why is this supposed to be a collaboration between engineering, product, and QA? What do these three perspectives represent? So in my mind, engineering represents the perspective of, how am I actually building my system? How am I going to make those dreams a reality, so to speak? Product is supposed to keep in mind the end user experience. How do we want the users to experience the system? What do they need from our product? And QA is supposed to represent the idea of stability. How do we make sure that those expectations are aligned? How do we make sure that they're aligned over time as we iterate and that we're not changing functionality accidentally? And so I think that these three ideas of how are we going to do it, what are we trying to actually do, and how are we going to make sure that those are aligned are the three key ideas. And making sure that those three perspectives are represented in your conversation is kind of the most important takeaway there, even if you're technically missing a person to represent that idea. The next key point that I think is the most important from behavior-driven development is the idea of articulating expectations from the client perspective. So why the client perspective? So this has become very relevant to me in my life because we're doing a massive migration of code from our legacy code base to a more modern code base. But ideally, the client experience should not change by this migration, which means that even though everything behind the scenes is changing, the user experience should still maintain its awesome experience from before, its same performance from before. So that means that what we should be articulating as the expectations from our system should not be the single outputs from a service, although those should be tested in unit tests, or the integration points, but the final experience. We want to make sure that that final experience is the same. And we want to make sure that we're understanding what that final experience should be. And then kind of the last thing that I think is really important from the idea of behavior-driven development is the idea of consistent non-technical terms. So for this, does anyone have a dog? One person with a dog, thank you. You had 2 dogs, okay, so twice the people basically. Okay, I also don't have a dog, but what I've noticed among dog owners is that many people have 5+ nicknames for their dog. So one of my best friends in college, this is her dog. He's the best boy. His name is Gambit. which we often call him Gambit or Gam or Gamba Bam. We also call him Shmagegi because he's a little bit of an airhead. Shmagegi means airhead in Yiddish. And that has been kind of nicknamed into Shmeg or Shmeggy. And then lastly, my friend is super attached to her son, her dog, so she calls him my son. So what this means is that oftentimes when we're having conversations about her dog, we're talking about Gambit, my son, and Shmeggy all at the same time. This keeps hitting the mic. And so that means that if you were listening in on these conversations where we're talking about Gambit, my son, and Shmeggy, you might think that we're talking about 3 separate dogs, or possibly 2 dogs and 1 person. And I think that this is kind of an example from real life, but this often happens in code too, where people who are really intimately familiar with a subject will create nicknames for an idea or shorten the idea. They'll create other technical terms of what it means behind the scenes versus what it means from the user perspective. And that means that when you're having that collaboration point between QA and product and engineering, you need to make sure that you're all speaking the same language and that you know what you're talking about. Okay, so we talked about collaboration, we talked about client perspective, and we talked about consistent non-technical terms. So let's see BDD in action. How would that have applied to our scenario from before? So from my perspective as the client, my perspective as the client in the post-trade system, that means that when I was looking at the I'm ready signal, I should have been saying, okay, well, how do I expect that signal to behave? And they could have been saying, how do we expect that signal to behave? And making sure that those expectations were aligned. But more broadly, what my team could have been doing is, what do we want the signal to do? What do we want the end user experience to be? What does it mean to be ready for post-trade? And is that the same thing that that signal represents? Are we speaking the same language? And finally, what is the client experience? What is the client experience of when the trade is ready? And are those expectations aligned? Okay, so we've talked about BDD, we've talked about articulating expectations. And I want to bring that back to this idea of the Venn diagram of what is your system, what do you think your system does, and what does your system actually do? And I think that can also be framed as how do you think people are using your system, and then how do clients use your system? So how you think people are using your system is all that configuration, all that configurability that you added, all of those future use cases that you account for. And then how client, and some of that is code that's not being used. That's complexity that can be removed from your system. Some of it you definitely want to keep because it's, allowing you to be used by clients to come. But you want to be conscious about what those points are. And then secondly, it's how clients are actually using your system and making sure that you're properly supporting them there. So now that we've talked about the idea of articulating expectations, I want to pass it back to Jackie to talk about evaluating trade-offs.
Cool. Hello. Okay. So now that hopefully you've articulated expectations, you've talked to your 3 parties, or you've talked about the different expectations of what you want to build, now you're ready to go ahead and build it. And so when we think about trying to build different solutions, there's a lot of trade-offs to be made in the architecture decisions that we're making. So I put together this word cloud. I think this captures a lot of very common architecture attributes that we have to consider about our system. And I think a challenge here is figuring out, of all these things, what do we care the most about? And I can say, from my own experience, if I look at this, I kind of want to care about everything. I think everything is important for my system, right? But the problem is that if I'm trying to optimize for everything, I often end up not optimizing for anything. And so it's important to think about, okay, what is the use case of my system? What do the clients expect to happen to dictate which attribute should I care about? So I'll take you through some examples between Jess's team and my team. So Jess, she says she works on an automation system. When I think about automation systems, I think about like an alarm clock. I set my alarm clock and I say, every morning at 8 a.m., wake me up. And if one day it doesn't wake me up at 8 a.m., wakes me up at 8:01, I consider this alarm clock broken. I expect every single day on the dot to wake me up at 8 a.m. And so for automation systems, I think an important attribute is performance. It needs to be real time. It needs to be immediate. And so that should be the driving factor in those systems. If I think about what technologies to use, maybe which queues to use, that should be the driving factor for which attribute I care about. Maybe on the other hand, talk about trading systems. So trading systems is about a lot of money. Clients are putting a lot of money into your system. They want to trade, have a high ROI. And so maybe the prioritization for those types of systems might be something like security and availability. So in our case for trading systems, we want to make sure that there's clear isolation between client workflows. Like I want to make sure if I'm trading on this system, no one else can see what I'm trading on. And if other people are trading, I don't want that to impact my workflows. And I want to make sure that if I'm using this system, that it's going to be available when I want to use it. Imagine logging on to trade at 9 a.m., then you log on, the system is down. Then you're not able to trade, you're not able to make money, and so you might not like the system as well. So this is an important attribute for trading systems. On the other hand, so my team, we're more focused on analytics. So I talking about a lot of workflows, workflow-oriented for how client operations can be handled in the system. For my team, it's a lot about analytics, a lot of data. How do we process this data in the system? Previously, I talked about my team, we have over 18 billion data points that we need to process into our system from different data sources. So we care about scalability. We want to make sure that we can handle this data, and this data is growing. Every year we get more and more companies that we're scoring or we're able to produce metrics on. So we need to make sure our system can handle that over a long period of time. And flexibility, talking about that rapidly changing industry and what does that mean for our system. If next year some data points become available by certain clients and we need to handle in our methodology of our system, can our system do that? Is it flexible to handle that, or do we need to rewrite it? Do we need to do a lot of work to be able to support that workflow? So I think there's a lot of things that you can prioritize in your system, and it's hard to pick one that you want to prioritize, and I think being able to pick one can just help guide you in that direction. I'm not saying that you have to only pick one, but being able to prioritize or know the list of priorities of which attributes matter to you will help guide in the design conversations of what you want to be focusing on. When I look at this, I think of all the technical attributes that are important to the system, but I actually think there's one very, very important thing that's actually missing from this word cloud, and I think it's this idea of cost. And cost in the context of money, cost in the context of time. How much time does it take to build something? How much time does it take if I want to pivot or remigrate? What is the cost in terms of what is available for me to use? And a lot of those non-technical attributes are really critical in terms of how much complexity my system might end up being. And I think oftentimes when we think about decoding unnecessary complexity, sometimes it's not the technical things that are making it so complex. Sometimes it's all the other attributes that are just involved with being a software engineer and working at a company that contribute to why our systems may be a little bit unnecessarily complex. So these are the trade-offs I think we have to consider and make outside of just what architecture attributes do I care about, but what are the other trade-offs just as a result of being an engineer in a space that I need to focus on to make sure I am decoding unnecessary complexity. So the ownership part is about people. What I mean by this is basically which team is going to be owning and writing the code, or which person is going to be owning and writing it. And what do they know? What technologies do they know? What languages do they know? That might dictate how they write the code, and that could also add unnecessary complexity if that doesn't fit in the wider context, or maybe the way they wrote it is not maybe understandable by other people. Whatever the case is, that human aspect of who is writing the code can lead to complexity. There's this concept in the world of architecture called Conway's Law. Conway's Law basically means the architecture of your system is a reflection of your organization, how teams are organized. And I often think, okay, well, which one comes first? Should I design the teams first and then mirror an architecture? Or should I build an architecture and mirror the ownership of the teams to reflect that? And I think if you go the route where you have this ideal architecture and you design teams to support it around that, there's also this cost of transfer and ownership, the knowledge transfer of, okay, someone else wrote it, but now I need to maintain it. And that's also cost that can add to more complexity in the system. The second thing I think about is this availability of resources. This is the cost of maybe the actual hardware, software, tools that you want to use. So depending on what your company has available, in terms of maybe if you're using hardware like machines, or if you want to use certain technologies, open source, message queues, databases, et cetera, depending on what your company has access to, you might end up having to choose a resource that isn't the most optimal. And if that is the case, you might end up having to add complexity to support that. You might need to add a wrapper, you might need to add some sort of translation or a transformation layer or something like that. And the trade-off of considering, is that worth going that route? Is it worth adding in that complexity just to use a certain technology? Is a trade-off that we need to consider as we have these design conversations. The third one is this idea, it's a concept often comes up in design conversations. It's the idea of designing for reusability. I think oftentimes you think, okay, reusable components. So like less is more, you write less code, maybe it's easier. I can just reuse what someone else already wrote. I think reusability is a double-edged sword. I think it works in some cases, but in a lot of cases, it adds a lot of complexity. In order to have something reusable, you might need to abstract something or make it so that the client has to have more domain knowledge or some business logic to be able to use that reusable component. And is it worth having that connection? Is it worth having that reusability? Because it might add some complexity there as well. So what I think about is, I think reusability is not necessarily, and it shouldn't be a design choice. We shouldn't try to build systems just to be reusable. We should try to build systems that work for the current use cases that we expect or the use cases that we know are coming, and the reusability will come as a consequence of that design. It will come where it makes sense. And I put here these 3 questions that I think are good questions to consider if you want to use reusability or if you want to build something reusable. And this first question is what is the current use cases? And current is a very key word here. I think it's important to think about, what is coming next in a year down the line. What do I know is going to be upcoming use cases? But there are also lots of use cases probably 10 years from now, 20 years from now. And we shouldn't try to predict what will happen then, because over time, things are going to change. New technologies are going to be available. New tools are going to be available. And so we shouldn't try to predict 20 years down the line of what we need to support. And we should design for something that we can support today. The second concept is the idea of what is the collective cost of change. So what I mean by this is oftentimes when you're writing code or developing systems, you kind of think in the boundary of what your team owns. So maybe you own some components in a wider architecture, and you think, okay, if I need to make this change, it's going to be a few lines in this service, a few lines in this service, and it's not that bad. With reusability, it's really important to think about, okay, what about all the other clients? So if I make this small, simple change in my API, does this now mean I have to tell 20 different people to change how they're integrating with my system? And that collective cost of change might be a lot higher than maybe them creating their own services, their own APIs to support their specific use cases. So what is the collective cost of change, not just for me evolving my system, but now that people are using my system as part of their workflows for all of us if they're going to be using my system as a reusable component. This third one is this design the result of reusability authoritarianism? I put this concept in quotes. I don't know if it's a technical term, but I found it from an article in Medium. And I think it's a really good way of capturing this concept of, at a lot of corporate companies or a lot of big companies, there is, obviously we want to make sure that we're being effective in how we're developing. And if there are reusable components out there, maybe we should use them, right? Why build out something new if something else already exists? But I think oftentimes we jump to using it because someone's like, yep, that's the right solution, go ahead and use it. But we don't think about the context of, like, okay, if we use it, now what does that cost if we need to ever change behavior? If they're not maintaining it, what does that mean for me? If I need to evolve my workflows, is it going to impact them? So whatever the case is in terms of that collaboration or coordination, that should also be a cost that we consider on top of just what is available in the space that I'm working in. So reusability, I think, is a great concept. I know I've kind of preached the opposite. I think reusability is good, but it requires a lot of work. It requires a lot of governance to make sure you're doing it well. And so if you answer all these questions and you're like, yes, this is still a good candidate for reusability, I think the few things to consider is, okay, these are things now that I'm exposing this API or this component for other people to use, how am I making sure it's being used in the right way? And like Jess was talking about earlier, Hyrum's law, the idea that if something is public facing, then any use case of it is a valid use case. And so I want to make sure if I'm building something usable, that no matter who uses it, they will use it in the way that I expect them to use. In other words, I want to make something that's easy to use and hard to misuse. So the 3 things to consider if you want to make reusability work is making sure that you have good documentation, which I would probably say is the hardest part about being an engineer, is documenting what I'm working on. But making sure it's updated is extremely important for reusability because it ensures the clients who want to use your system are using it in the way that you expect them to be using it. There's a lot of tools to make it dynamic, make it programmatic. So if this is something that you also don't love doing, I definitely recommend looking at some of those. We can talk about it later. But making sure documentation is updated is so, so, so critical if you want other people to use your system. The second concept is simplicity of integration. So when I think about reusable systems, oftentimes if it's like an API, there's multiple parameters. Because if it's reusable, there's probably multiple ways to use it. There's that optionality of if I use this API, there's different code paths. And in order to indicate which code path I want to use, I need to pass something in. I need to pass a flag or a parameter to say, this is the use case that I expect. And oftentimes for very reusable components, they have a lot of parameters. And it can be very, very difficult to understand, okay, what is the order I need to pass in for all of these values? What does it actually mean when I pass it in? And so as an owner of a reusable system, to think about that integration and how can you make it easier for your clients to use. So maybe one example is you have a custom object so that there is no way to misuse it. There is only one way to use that component. And it's very, very clear to your client what they need to pass in terms of getting the behavior that they expect from the system. There's this concept, it's called KISS. It stands for keep it simple, stupid, or silly. And it's a good thing to keep in mind when you're having design conversations is how can you continue to make things simple and easy for people to understand. There's this idea also that humans, we often abstract a lot of details because we want to look things far away. We don't want to get too in the weeds. Sometimes we just want to use things that we think work. But systems, they do not work that way. They need to know every single permutation of every detail. So we need to make sure we have that alignment also with reusable components. This third concept is called don't write code when it's not needed. And the principal abbreviation is YAGNI, which stands for you ain't gonna need it. So here, I think the idea is there's oftentimes we write code and we realize, okay, we might not need it today, but let's just check it in for now. We'll get back to it. We'll probably use it 2 years down the line or maybe even a week down the line. And most times when we do that, we probably don't go back to that code. We probably let it sit there, in GitHub and just don't touch it ever again because maybe it's not relevant anymore. Whatever the case is, when you have reusable components or generally any code in GitHub or anywhere in terms of source control, if you add code that isn't going to be used, a lot of times it can be confusing to clients when they look at your code to be like, oh, is this actually used in production? Or what does this actually mean in the context of the system? So adding in code that isn't needed can also add unnecessary complexity to the system that the client doesn't understand. I think when in doubt, the motto of our talk today is less is more. You want to make sure that you're only putting in things to your system that are integral to how it's going to be used and to ensure that people are using your system properly and as you would expect them to. Okay, so we've talked about articulating expectations. We've talked about trade-offs. And now that you've hopefully made some decisions around trade-offs, now we need to talk about compromise of how do we get the right stakeholders on board with making sure that we're building the correct solution that everyone understands. So I'll start off with this quote. This quote is from a lead dev article about RFCs. The quote is, while programming is primarily an individual act, building software is a social exercise. And this is a really, really important quote because oftentimes we forget about this human aspect of working with other people. And if that is overlooked, sometimes that leads to a lot of complexity that accidentally gets added into our system. Like Jess's example earlier talking about producers and consumers, if we just talk to each other, all of that complexity might have been avoided. But sometimes, we jump to just writing the code. So I joined ESG, my new team, last November. This is actually the first PR that I wrote, and it had 20 lines of code, if you can see right here in the top right. So I think writing the code was the easiest part. Maybe you're like, oh yeah, it's pretty straightforward, 20 lines, how complex can that be? However, writing the code is often not the challenging part. It's where do you write the code? Where should it live? What does it mean? What's the implication on the whole system now? So writing the code, I was able to do really quickly. But getting it merged was the challenge. I need to talk to a lot of people. I need to talk to people on my team to say, okay, I wrote this code. Does this make sense? Does it follow the same verbiage that other places in the code are using this? Is it written in the right place, the right files? And then there's upstream teams. So I actually made a little change to a parameter of an API. And the upstream teams, I need to communicate to them. Okay, so I made this change. Is this what you expect? Can you make sure that you're passing in the right variables? I need to make sure that they were on board with the change that I was making. Then I talked to downstream teams because it changed the behavior of the system. And I just say, okay, FYI, once this is merged, all of these changes are not going to impact your system. Do you expect this? Do you need to handle it differently? What does it mean? And then to the product, because this is client-facing. So I just make sure, okay, I made this small change, but now it's going to impact what the client is seeing. So is that also what we intend to do, and what do we expect to do? So this is just a quick illustration of the idea that, yes, writing code is pretty straightforward. Writing code is an individual act. We can do it, but getting it into a system, getting it into software, oftentimes requires a lot of people. And that social aspect, that human aspect is often overlooked. And that is a main reason why a lot of systems are very, very complex and might have that unnecessary complexity. So I think about this example, it kind of got me thinking about software engineers in the world. And I kind of think there's two categories of engineers out there. We have our engineers who love to socialize, who love to talk to people, just love to walk around and ask questions. And then we have our C++ users. I think oftentimes we forget about the social aspect. And the social aspect, I think, is so important to make sure that we're building the right solutions. We're making sure that we're accounting for all the different possibilities, the optionality of the components that we're using. And so in this context of compromise, I want to pass to Jess and talk about two tools in terms of how you can make compromise and how you can communicate with other stakeholders.
Awesome. So we talked about kind of decoding complexity and this social exercise of engineering. So I want to talk about a tool for visualizing that socialization. So that's C4 diagrams. So C4 diagrams is a consistent language for visually representing a system with distinct layers of abstraction. We've actually already seen an example of a C4 diagram in this talk. But there are two aspects of C4 diagrams that I really like and I think are really important. So I want to focus first on the idea of consistent language and the idea of distinct layers of abstraction. So we're going to start by talking about the idea of distinct layers of abstraction. So C4 diagrams emphasize 4 layers of abstraction. They talk about system context, containers, components, and code. So there's 4 layers, all of which start with the letter C if you squint, and that's why it's called C4. So we're going to start with the highest layer of abstraction, which is the system context. So this is involving your systems, and which is the groups of services in your codes, oftentimes represented by teams or maybe organizations, and then how users interact with those systems. So this is the highest level of what are we trying to do and how are people using it. And then you can dive into each of your systems and talk about the containers within your systems. So containers are the deployable units within your system. So those are your services and how they're interacting with libraries and databases. Each of these are individual deployable units. You can dive in even further inside of your containers and talk about components. So a component is a group of functionality within a specified container. So I think that this layer is a little bit more abstract. The other two I feel like are a little bit more concrete. I can kind of see them in my organization. I can see them in repos, and then the orgs that those repos belong into. So this one I think requires a little bit more thought. So for example, if I had a service and it's taking in a request, it's doing some business logic on that request, and then I'm inserting the result of that business logic into a database, then there are several groups of functionality at play. So there is the group of functionality taking in that request, processing that request. There is a group of functionality that is doing the business logic on that request, translating it. Sometimes that's even multiple components in and of itself. And then there's another component which is interacting with the database. And I think what's kind of important here is I often see that this is confused with containers when people make visualizations. So what I see here a lot is that they'll have a service interacting with a table. And a table is a group of functionality within a larger database. The database is the deployable unit. That's what you're designing as a whole. And then the table is a small piece of that. It's a group of functionality within that. And so what that means is that if I'm looking at a diagram and it has a service that's interacting with a specific table, then I have 2 different layers of abstraction. It makes it a little bit harder to know what's going on and what things represent, especially if there's a separate thing on that same visualization that also is a database. And then you can dive even further into each of your components and talk about the code that makes up those components. So that's your classes and your functions and how those interact with different schemas. So what I think is really important here is the idea of there being different layers of abstraction, and then making sure that you're consistent with your layer of abstraction when you're making your visualization in order for people to have the correct context when looking at your visualization. Then the other aspect of the C4 diagram that I like is the idea of that consistent language. So C4 diagrams provide you with some different visualization tools. So they give you this lovely box to represent a service. They give you a cylinder to represent databases, and then arrows to represent the relationships between different units. However, I think that you can even take this a step further. In my org, we kind of built upon this consistent language, and we decided that we wanted people to be able to know what the relationship was just by looking at our visualization. So we decided, okay, well, a squiggly line is going to represent an API, and a dotted line is going to represent a RabbitMQ. And we made this language consistent. We made a little legend that was on the right-hand side of all of our visualizations. And that meant that people had context when they were looking at our diagrams, not only of the layer of abstraction, but also the language being used. And so even if you didn't know or have the context on the system as a whole, it gives you a better context on C4 diagrams to take into your next conversation. So I wanted to also talk about C4 diagrams and actions and seeing them being utilized on my team. So we had I talked about how my team has many, many interconnected services. And one of such interconnected services is the status publisher. So what a status represents is, how is my trade doing? My trade's doing really good. And when there's a status on that trade, it needs to be told to 4 separate clients. So we need to tell long-term storage, so we can remember for all of time how well my trade was doing that day. I need to put it on the client UI so they can have immediate feedback on how my trade is doing. We need to tell automation, because if the trade is doing well, we might want to take a follow-up action automatically. And if it's not doing so well, then we don't want to take said follow-up action. We also want to tell auditing. Auditing is our client's long-term storage. And we ran into this problem where auditing wanted a lot more statuses. They wanted to know not only that our trade was doing well, but they wanted to know why it was doing well, all of the different steps that we took to determine that it was doing well. And so we said, okay, we have this problem that auditing wants more statuses, so we're going to publish more statuses. We're going to add that transparency into our system. So you might be having your children's TV show moment, your Dora the Explorer moment, where you say, well, Jess, what about those 3 other clients? How are those being impacted by those increase in statuses? And I think that that's an easy question to ask if you're looking at this diagram, where you say, okay, what about those other interconnected systems? But if you're focused on the problem at hand of how is the status publisher communicating with just the audit team, then you might be zeroed in on solving that and not think about how it's affecting the other services in your area. And so now that we know that there are these other systems, we can rethink, okay, is this the architecture that still makes sense with this different layer of granularity? Or do we need to refactor into new service? Do we need to add a filter? And it kind of sparks those conversations. So some takeaways here are what I call the butterfly effect. So it's this concept of how if a butterfly flaps its wings in Brazil, then it's going to create a hurricane in, I think, the UK. That's topical. So this is the idea of purposeful changes being created to help one system may have unintended consequences on another system. And having that visualization helps us realize those consequences. So I know that your reaction right now is, I love C4 diagrams. I want to make one too. So you're going to leave this conference. This is going to be exactly what happens. So you're going to make your awesome C4 diagram, which means that you're going to have an awesome C4 diagram, and then you're going to make a change to your system. And this is where it gets tricky. You're going to update your awesome C4 diagram. And that last step is where things often go a little bit wrong. So oftentimes people make the diagram, and then they have the diagram, and then they make changes to the system, and those are not necessarily reflected in the C4 diagram. And this can be really helped by automating that process. So we've been looking into our areas, ways for it to look at the code and automatically generate a C4 diagram. But I also think that there's ways to kind of help with that updating manually. I call this manual automation, which is not really term, but I think that there's ways that we found in our area to help with that manual process. So one is that we have an annual architecture summit where all of our teams come together and we say, here's what my team does, here are the problems that my team is facing. And if you're presenting every year on what your team does and what your team is facing, then you need a visualization for that. And that is a great time where everyone goes and they update their C4 diagrams so they can make their slides. So I think one way to kind of encourage people to keep it up to date is by having a set time in the year, kind of an external source to have people update their diagrams. Another way is we have found bringing those diagrams into our document, into our conversations, into our design discussions. Not just having it sit off to the side for newbies who want to see how our code works, but bringing those diagrams into my design discussion and saying, okay, if I'm going to reorganize my system to look like this, what is that going to do? And that means that at the end of your design discussion, you have already updated your C4 diagram, and you don't have to go do it later. So here are kind of some ways to make it a little bit more part of your day-to-day life and make sure that this tool is being capitalized on. I also really like this talk made by Simon Brown, where he talks about a language that he created that helps with kind of the consistent language of C4 diagrams, and it helps merge those different layers of abstraction and make sure that they're distinct and make sure that you're using them correctly. So highly recommend that talk. So some takeaways from C4 diagrams are it's helpful for both experts to make sure that they're understanding the complexity of their system. It's helpful for newbies to understand their current system. So it's a way of decoding your system and making sure that you understand the complexity and the interconnected services at play. It's also a time to think about how your strategies for updating your documentation and the challenges with that. I also think that it's, again, the concept of the butterfly effect. If you have a complex system, then a change to one system might have unintended consequences for another part of your system, and making sure that you're visualizing that and having it in front of mind. Again, decoding that complexity. Okay, so we talked about this idea of, well, programming is a primary individual act, building software is a social exercise. So we've talked about a way of visualizing that social exercise, but what is another way of codifying that social exercise? So this is where RFCs come in. So a RFC, or a request for comments, is a forum for holding discussions and making decisions in your area. So I wanted to talk about the life cycle of an RFC, which is, again, that kind of documentation and a forum for making those decisions. So the first step is the proposal. So this is writing up the decision that you want to make. And I think that this is often a huge barrier to entry with requests for comments, is making that first request for comments. Because I can speak for myself, I don't like writing essays, so I didn't like the idea of having to write an essay. I think what's really important about this step is thinking about what am I actually going to communicate, and you can communicate that in whatever way you want. A visual aid, such as a C4 diagram, can often be a helpful tool. But also bullet points are great. Oftentimes people don't want to read an essay just as much as you don't want to write an essay. So making sure that your point is coming across. And also making sure that you're very specific about what you're trying to solve in this RFC. So, you have the whole universe of problems. We talked about that big square, but focusing on the specific problem at hand. In this case, focusing your RFC can create more bang for your buck. So after you've written your RFC, then you can talk about the commenting period. So this is when you are asking for feedback on your initial idea, on your decision that you're trying to make. A helpful thing for this is creating a specified deadline of we are taking comments until this day. We found in my area that a week is too short, a month can be too long. So finding the balance of your area, but a deadline helps motivate people. We've also found that this oftentimes leads to discussions that are relevant to the topic, but also tangential, like, well, this helps here, but it reminds me of this other problem in another spot of the system. So again, trying to make sure that your RFC is focused on the problem at hand, but also that you're remembering those other comments, those other ideas for future projects. So the next step is once you have all that input, you can make a decision. So a good format for that decision is we oftentimes supplement our RFCs with a design meeting where not only can people comment online, but people can comment live and get context for their comments. And afterwards, we summarize all of those comments into a specific decision. We have taken this question that we're asking, we've made this decision, and this is why. And after you have made that decision, then you need to archive it so that you can remember afterwards why you made that decision. And this is another kind of point where making sure that it's findable and not just kind of sitting somewhere is very important. I've often found that attaching it to the repo is very helpful, or saying here are documentation relevant, and that way it's a little bit more findable. So as we talked about with RFCs, are these ideas of kind of leveraging the social exercise around you, talking to the people around you, decoding the complexity of a problem with the help of your peers. We've talked about how having a smaller RFC, having a smaller problem statement can help to facilitate that conversation, make sure that you get a more defined answer. And so in that sense, we've talked about decoding complexity and about how a focused RFC can be useful. So I think with that, I'm going to pass it to Jackie to talk about iteration.
Okay, last section. So hopefully now you've learned, okay, for decoding complexity, I need to go through the steps for each problem of articulating what I expect, figuring out what trade-offs I care about, maybe making the compromises that matter the most to me for my system, and maybe building my system. And then now we need to iterate. We need to figure out what makes sense in today's context and what can I do moving forward. So I'm gonna start with another quote, another great quote. This is from the DevTrinity conference. The quote is, if your design attempts to satisfy everyone, you'll likely end up satisfying no one. I want to start here also with a story. I don't know if anyone's heard about Aesop's fable about the man, the son, and the donkey. Has anyone heard this story before? Oh, okay, great. So we have some people who know it. So the story, the way it goes, is a man and a son want to sell a donkey at a village. And so they need to bring the donkey to the village to sell it. And along the way, they get a lot of critique, kind of like people calling out and saying different things to them along the way. So they start off by first, they carry the donkey, maybe they have a harness on the donkey and they're carrying the donkey to the market. And someone yells out, hey, you know, the donkey is meant to be ridden. Like, why are you just carrying him along? You should ride him. And they're like, okay, yeah, that's a good point. So the father puts his son on the donkey and they keep going. And they keep going and then someone yells out, hey, why is your son riding the donkey? You know, you're the older man, you know, you need to take care of your joints. So why don't you switch? Why don't you make sure your dad is riding the donkey? And they're like, okay, that's a good point as well. Like, we didn't consider that. So they switch. Now the son is carrying the donkey and the dad is riding it. And they keep going, and then someone else yells out, hey, like, you can both ride the donkey. Like, why not you both ride it? It can carry both of you. It's there to be ridden. Why waste any energy? And they're like, yeah, that's actually another really good point. And so they both get on the donkey and they keep going. And they're almost at the village, and then someone's like, hey, you know, it's like you can't have two people on the donkey. You're gonna tire it out. It's only meant for one person. And they're like, okay, you know, I give up. I can't accomplish everything, satisfy everyone. And they end up just carrying the donkey on their back into the village. And so the moral I think of that story is you really can't satisfy everyone. There's always gonna be opinions out there of people who expect certain things or care about certain things. And it's just important to think about what is most important for my client, for my system, what do I wanna do, and have that drive your decisions moving forward. So in the context of iteration, I want to talk about an example, specifically deployment strategy and how we deploy code. So I actually used to be on a sister team to Jess. So I actually also used to be in the trading systems space. And this was often a very critical part of designing how we deployed our software in our systems. The reason why this is critical is because as trading systems, you know, we have to have that security of making sure that one client's workflow is isolated and does not impact any other clients. And so we think about deploying strategy, we need to make sure when we deploy the code, it's not going to impact anyone else. Any of that will minimize any risk for the client. So let's just say, you know, we have some code, we have some business logic, we wrap it in a service. And we want to deploy that code, and we actually want to deploy multiple instances so that each client has their own service. We want to make sure we have total isolation so that one client's workflow cannot impact any other clients. So what that means is you still have that one golden source of your code on GitHub, but you're spinning up multiple instances for every single client. So what that could look like is it could look like this, maybe scale even bigger. You have one machine and it has tons of instances. And if you remember earlier, Jess was talking about having 900 clients. So you might be asking, okay, you're gonna have 900 instances on that one machine. So there's some considerations here. You know, there's some value of doing this, but there's definitely a lot of caveats and trade-offs. Like if you do it this way, you have a very clear upper boundary of computing resources. So actually, this might not actually work because if one client is trying to book like 1 million trades in one day, it actually might impact other clients on that machine because now it's conflating and trying to compete for the same resources. So maybe you go with a different strategy. You say, okay, I'm gonna have one machine per every single client. And that way each client is completely isolated. It has its own service, its own machine. And now there's no way that my client's workflows is gonna impact any other clients. So this is an interesting one because long, long ago, so before the world of cloud computing, we had physical machines. And so if we went the route of this, we would need 900 machines. We would need a lot of machines. And probably more expensive than the machines, we needed space to hold the machines. We need to rent out building space to hold all of these machines in order to create this isolation for the client. And so it's interesting to think that back then, that was the constraint that we had. And so we had to pick a decision, a trade-off of our deployment strategy that fit with the times, that made sense back then. So actually we made decisions back then that, okay, maybe we probably can't go this route. This is very expensive. We can't have 900 machines for each client. But over time, as cloud computing became more available, this actually made sense. This made sense as a decision. So it's clear the context has changed over time, and then now we have to iterate. And now we have to decide, okay, well, there's a cost to migration, but is that cost worth it in order to iterate my solution to incorporate the new resources that are available? So the takeaways here, I think, is the idea that context changes over time. I think decisions that made sense at one point may not make sense in the future. And similarly, the idea of complexity. Sometimes necessary complexity over time will become unnecessary complexity. And so taking the time to reflect and think about, okay, decisions and historical rationale in the past, does it still make sense today? Do I have more resources today? Has technology changed today that can now support other solutions? Also, this idea of client workflows influence technical solution. So this ties also back to what Jess talking about with behavior-driven development and the idea that we want to prioritize what our clients' expectations are and use that to guide our technical solution. And this also changes over time. You might have new clients, you might have new workflows to expect and to support. And so understanding how the client is evolving should influence how your system is evolving. I like to think about this from the context of technical interviews, which I'm sure everyone here has done. And if you have a technical interview, it's sometimes pretty clear what the interviewer is trying to guide you towards. They're kind of asking you leading questions. They want you to use a stack or a hash map. It becomes quite clear what is the quote unquote optimal solution. I think in the real world, that is often not the case. There often isn't one perfect solution. There's all these good options, and they all have different trade-offs. And I think realizing and recognizing that over time, those trade-offs are also going to change should impact how you want to iterate your solution. This last concept is the cost of incorporating feedback also increases over time. And I think this is really important to consider when you think about trying to make those compromises and trying to understand what you want to do, get the feedback from other people early on through RFCs, through requests for comments, is if you have something that's in development, it is quite easy to change it or to delete some code. But if you have something that's in production that clients are using and billions of dollars are going through, it is a really high risk to make any changes to it. And so that trade-off, I think, is also important to consider as you want to iterate your solution, is where are you in the development lifecycle of that software. So this is a picture of me. This is me touching the Greyfriar Bobby statue in Edinburgh. Was curious if anyone knows it's in the UK, so I guess it's in the UK technically, or Britain. But I'm not from here, clearly. But has anyone been here? This is in Edinburgh, in Scotland. It's like the dog statue. Did you touch his nose when you were there? Okay, maybe it's just a tourist thing. But sorry? Oh, okay. So when I was there, I'm a tourist from America, so the tour guide was like, oh, you should rub his nose for good luck. And I was like, okay, sure, why not? And so I rubbed his nose, and then I went home and I Googled, why do I rub Greyfriar Bobby's nose for good luck? And I could not find any article to explain why you should do that. And I actually found a lot of articles that said, do not rub the statue's nose because it's causing irreversible damage to the statue. And so I thought, okay, that's kind of similar to our systems. With a lot of systems we have, there's certain decisions that are made in our system, but over time, often that historical rationale is lost. And have you had new people join your team, they're not gonna know why things were written the way they were. And oftentimes they just keep adding more code, keep adding things to build out new features without stopping to think, okay, does the rationale of why we added code historically make sense in the context of today? I think it's important to think about that before we get to a state where our system is also irreversible and we have that damage that we're not able to fix it or refactor it. And we want to make sure that we're iterating on our system before it gets to that point. Okay, in the context of feedback, the cost of incorporating feedback, there's also this concept of swoop and poop. This is very common in like technical leadership. And the concept is basically when someone comes in, when you're quite deep into development, you're quite deep into implementing something, they come in quite last minute and they say like all this disruptive feedback and then just leave. They just assume that you're gonna clean up all this mess based off their feedback. And this is an important concept, both as trying not to be that person, but also to recognize when someone is trying to come in and swoop and poop on your ideas. I can definitely speak to my own experience. I joined my team somewhat recently, still last November, and I was like, okay, I need to recognize that things are gonna iterate over time, so I don't want to just swoop and poop and change everything last minute just because I'm new here, but to question and understand what is the rationale for why things are the way they are. And also the idea of if someone comes in to swoop and poop, how do you communicate to them the compromise or the scope of what you're trying to work on? And maybe you need to table the conversations for later. Maybe you need to have other RFCs about other conversations, but how to scope conversations to make sure that no one is coming in and derailing what you're trying to do. So when I joined my team, I was able to see like the way our systems interacted. And I think one interesting component or concept that came to mind was this idea of coupling versus cohesion. So coupling is the idea of the degree of interdependence between components in a system. And cohesion is the idea of the degree in which different components work together to solve one purpose or one goal. So I'll talk through a C4 diagram of my team's architecture and kind of highlight where we had to have this trade-off of coupling versus cohesion and what does that mean today and how should we evolve it moving forward. So I'll start off with this box, this service. We had a service that basically computes ESG scores. So we need to take in a few data points and new components to be able to compute a score for each company about their ESG standing. So we need something called company classifications. This basically means that we score companies, like oil companies, different than how we score software companies. So they obviously have a lot of different attributes, so we want to make sure that we're accounting for that in how we score their ESG score. So that's very critical. And on top of that, we also need some data. So we need some data based off that company. So once you have a classification of a company, so the company maybe is an oil company, we need certain data points. We might care about how many environmental fines they had over the last year. Maybe for a software company, we care how many data breaches have they had over the last year. So there's different data points that matter, and that's dictated by the classification of that company. And then we have a model. We have a model that determines, okay, given this classification, given this data, what is my ESG score? How do I want to weigh these different data points to compute a score that could be normalized across all the companies and that can make sense in the context of when I'm doing trading? What does this number actually mean for me? So you can see here I've had these arrows all pointing in one direction. And the reason for that is kind of back to the availability of resources, how the components were designed. So a lot of these are designed as libraries. So they kind of have that one-way interaction. And as a result of this in and of itself is a lot of complexity, but it means a lot of these components are very coupled together. We need to make sure that we're using the outputs and inputs of each of these components together to end up getting this ESG score. And often a very big indication of if your components are very tightly coupled is if you're trying to implement a new feature and you're not sure where it belongs. That means that the boundaries between your components are quite blurry, and it can be quite difficult to know, okay, what makes the most sense? What will be the best option for where I should add that feature? So, for example, I've talked about how company classification dictates the input data, which may dictate how the model is run. But maybe we have a feature that we want to support, and we want to say, based on the data that the company has available, that should determine its classification. So if a company hasn't disclosed certain information, maybe it shouldn't be an oil company. Maybe it should be something else. And so when I look at this diagram, I think there's a few options of where I could add this logic. I could add it inside my service itself. I can have some sort of logic or layer inside it to combine this information and maybe pass that back into the other components that are relevant. Or I can have an arrow that connects these two components. The main point of the story is to kind of illustrate that all these components kind of depend on each other. there's nothing that can really happen in isolation. It needs the inputs across all the other components in order for it to perform the logic that it expects. And as a result of that, it's very, very coupled, meaning that the development and the deployment of each of those components are also very coupled. But I think coupling in and of itself is not inherently bad. So that's where the cohesion aspect comes in. So cohesion is the aspect of, yes, your components are coupled together, but it allows you to do certain things better. It makes more sense together. So one example is verbiage. If you have variable names, maybe it's easy to understand to jump into each component and to trace through the entire workflow of that code path. So maybe that is consistent. Maybe the style is also consistent. Maybe you have linting rules set up so that everything is connected to each other. And so again, it's easy to develop and to understand what's going on. However, there is also that bottleneck of, yes, it is cohesive, but maybe because they're coupled, that means that I'm not able to develop on one without impacting other engineers who want to develop on other ones. So we're not able to work in parallel, or we have to make sure everything's deployed together in order for it to make sense in the context of a productionized workflow. So in this context of coupling and cohesion, I think one thing that is good to aim for is this idea of high cohesion with low or loose coupling. So I think no matter what in terms of end-to-end client workflows, if you have a distributed system, if you have a lot of components, they're going to be coupled in some way, but is there ways to create tighter boundaries or clear boundaries between things? Is there contracts we can make across our components and things to ensure that there's clear ownership of different parts of the workflow? Okay, so I talked about the swoop and pooper. I think what I would suggest as the alternative to the swoop and pooper is the 5 whys, which I think is an informal term coined by our CEO. And the idea of the 5 whys is that when you go to a design conversation, you want to question and challenge the default. Instead of going in and just being like, this is my idea, I heard your idea, this idea is better. I just want to share my idea because I know it's going to be the best idea. Instead of jumping to do that, just wait and ask why. Understand what is the reason why they're suggesting this idea. What is the reason they're choosing a certain technology or framework? Maybe there's some sort of historical context that you're not aware of. Maybe there's some perspective of them talking to a product team or another engineering team that is the rationale for why they're going that direction. This concept of the 5 whys doesn't necessarily literally have to be 5 whys. You could do this. I think I've seen cases where engineers literally just keep asking why. But it's more about this concept, this mindset of challenging what is the expectation. And by challenging the expectation, we're able to really drill down to what is the root problem that we're actually trying to solve. Is there some specific attribute from our client's workflow or expectation that we need to prioritize in building our system? And what is that? And how do we make sure that we have a very focused view of that very specific root cause in order to have the right solution for it and not try to do 20 things at once and try to solve for everything in the world? And if we're able to focus on that specific solution, we're able to have a simpler solution. It doesn't have to have too much complexity. We don't have to try to have different optionalities of the 5 different ways our clients can use our system, but we can support the one actual use case that we know our client wants to use within our system. So I'll summarize by kind of what to-dos and what not to-dos. I'll start off by saying, have that focused solution, that narrow scope of what you're trying to do. I think a main aspect here as well is technology is always evolving. Thinking back to 10 years ago, what was available versus what's available today. There's so many more tools out there today that now are creating opportunities for new solutions. And so probably 10 years from now, there's going to be a lot more solutions as well and a lot more technology that's available. So trying to be focused on what we're trying to solve today will allow us to have simpler solutions that does exactly what we expect it to do. And it won't be that big box that Jess was showing earlier of all the other things the system is doing accidentally. And this idea is simple. I think I can speak from experience. As an engineer, I kind of want to jump in and write some code as soon as I see a problem. But oftentimes, this aspect of keeping things simple just requires that human conversation of let me just understand very deeply what we're trying to solve so I can make sure my solution is solving for that. So keeping things simple, the KISS, keep it simple, silly, or stupid. And the idea of you don't need a design to reuse. Reuse will come as a result of your design where it makes sense. It allows you to ensure that you have a simple solution that makes sense for the use case you have in mind. And if there are future use cases, you can continue to iterate your system to support those. And then reflect and iterate. Think about what makes sense in the context of today and focus on that. And as new use cases pop up, as technologies pop up, to reflect and iterate, think about the tools that you have with C4 diagrams, if you want to do design conversations, RFCs, to make sure that what you're building today makes sense for today's use case. Don't optimize for everything, because if you try to do that, you probably won't optimize for anything. Okay, so just to kind of summarize everything we talked about, it's been these 4 categories, and I think what Justin and I really would like is, take this opportunity. Hopefully from this conference you can go back and you can use these questions, and you can think about your system, and think about the workflows that you have in building architecture to ensure that you are able to build simple solutions that don't have unnecessary complexity. Think of this concept of less is more. The more simple it is, the more easy it is to maintain, to use, to integrate. And so if you are trying to think about trying to build a new system, trying to think about how do I solve this problem, how are you articulating those expectations? This is the BDD, the behavior-driven development. How are you having those conversations? Are you having those conversations? Who's in that room to make sure they're able to understand the expectations here? What trade-offs are you making? This is that word cloud, all those attributes, and then the cost. What is the cost in terms of the attribute that you're going to prioritize? What do your clients care about? What is the system supposed to be doing? And how do you prioritize a technical solution that accounts for that attribute? How are you making compromises? And you're going to do the C4 diagrams that Jess was talking about. So everyone's going to go home and make an awesome C4 diagrams. But how are you using that in conversations? Are you having RFCs to make compromises? And is everyone aware? Is everyone on the same page about what that means? And then are you iterating? This is the most important, I guess not the most important, but maybe the most often overlooked, is we build something and we kind of move on. But have we taken this time to stop and think of what the context of the system is today? Does that make sense? Or should I iterate on my system and account for the things that are available to me now? Oh yeah, some shout outs. We had a lot of support from Bloomberg, so big shout out to everyone who's been involved. But if you are interested in talking to us, or I guess Bloomberg, feel free to reach out. But yep, that's the end of our presentation.